Good morning. Welcome everybody to the Oracle Database 23C What's New in SQL session. It's going to be a packed session as there are so many new features that I want to share with you. My name is Robert Pastijn, I'm based in the Netherlands and I'm one of the outbound product managers in the Oracle Database product development team. So let's get started. In 23C, the key goal in the development of the new features was making application developers even more productive with simplicity and enhancements in, for example, SQL. It should be easier to retrieve or store the data you need as a developer, while at the same time we need to keep the nice things that the database already provides in availability, security and performance. So the Oracle Database development team is pleased to announce the next long-term release of the Oracle Database, version 23. In this new release we follow our previous long-term support release, the Oracle Database 19C. Its extensive new functionality is based on feedback from our customers, and while Oracle has already offered the most complete set of features in the industry to ensure the most secure and performant and highly available database, there's always more we can do as new data management requirements arise. In Oracle Database 23C, we focused on making it easier for developers to build their next generation of data-driven applications using our database, regardless of the development approach or style. The slogan for the 23C database is therefore App Simple. And just for your information, the 23C version of the database is available at this moment. We have a free edition for people to get a jump start when you want to run things on your own system, and we have the 23C version available in our Oracle-based database cloud offering. The non-Oracle cloud version of 23C as well as 23C on other platforms than Linux are still in the pipeline. Please keep an eye on the relevant support pages as we will publish information in My Oracle Support when it becomes available. And just to be sure, what you're about to listen to is a high-level overview of some of the 23C SQL features. I do not aim to be complete as there are over 300 new features and enhancements in this release, so therefore please check the manuals for exact details on usage and restrictions. We simply cannot cover everything with all of the details as this would be simply boring. First couple of slides, a quick overview of the new things in SQL+. So the enhancements may make your life a lot easier when writing scripts or simply using the tool. So some of the enhancements will apply to SQL as well, but SQL sometimes might be lagging behind a little bit, so please check it carefully. So the OERR command. So one of the first things you can do here is use the new OERR command that will quickly show you the full calls and action text we have in our libraries. During the ramp up to 23C, the development team has made a lot of effort to make the errors easier to understand and to provide you with more information than we did in the past. So if you do encounter an error, use the OERR command from SQL+ to get some more details. And if you really like the long explanations in the errors, you can even turn it on automatically by setting the Set Error Details to verbose. If you encounter an error, you always get the full text back without the need for the OERR command. And if you want to turn it off, simply set the error details to off. So when running scripts from SQL+, sometimes input is needed. And here we get to the argument command. So you can either supply the arguments in a call to the script, but in case you forget to pass the parameters and didn't prevent that in your script, nasty things can happen while executing the script. So using the argument command, you can now ask for values for the arguments the script needs in case they have not been set. If an argument has been set, SQL+ will simply skip over these lines and continue with the rest of the script. So sometimes scripts need secure information, so therefore the arguments command. But if it's really secure information like a password, if you don't want to have this information reflected on the screen or in your logging, you can optionally add the hide command to the arguments command. And as you can see, the value you typed for the password is not reflected, but it's still available in the argument. And in case you already know what the value should be if no input is given, you can use the default option in the argument command to specify a value in case no arguments have been specified when you call the script. So the argument command, together with the hide and the default options, should, I think, solve a lot of issues we currently have with scripts running in SQL+. So the ping command. So another nice thing is the inclusion of the TNS ping command in SQL+. So clients starting in 23C and higher can use the ping command from the SQL Plus prompt, just like they would use for the TNS ping command from the command line. So this will especially appeal to those users using instant clients, as at the moment there is no TNS ping available for instant clients. But starting 23C, it's built in, so now it is. The ping works with both the Easy Connect strings and the entries in the TNS names.aura that SQL Plus is using, and it will actually also display which file it's using. So no more searching around where the value should be or was taken from. So this was the end of the shortlist for SQL Plus enhancements. So now it's time for the things that have improved in the JSON handling of data. So the Oracle database already had a lot of options and functions to store and retrieve and manipulate JSON in the database. However, we know that JSON is getting more and more important, and that the handling of JSON documents sometimes even decides on which database to use in the background. So we want to assure everybody, both the DBAs that are used to relational databases and the developers using the JSON documents, that the Oracle database should still be the database of choice. So let's see if the following enhancements make your life easier and understand why. First of all, data retrieval. So it's very easy to query JSON documents in database 23C. The simplest way is to use the so-called simple dot notation. So we just need to create a table alias, in this case it's M, and then we can refer to a value, a key in the JSON object by using table.column.JSON field name, JSON key. The extracted JSON field is treated exactly like a column, and you can use this notation anywhere a normal column data could be used. For example, in the select clause, in the where clause, order by, group by, having, etc. If you want more control, or you want to specify the way the data is returned, specifically like a number, if you need a number, you can use the more powerful JSON value function, which takes a full JSON path expression, including any conditionals, to specify what to fetch. And it also allows you to specify the data type to return and what to do if there's no value to fetch or data types cannot be converted. Now, storing JSON data has historically been done in a varchar2 or a CLOP column or a LOB column, simply writing the text into the database and therefore using the database as nothing more than an expensive file system. So this changed in 21C when we introduced the OSON type, or the Oracle Stored Object Notation type. We already had a kind of a binary JSON way of storing things, but now we've formalized it. So from the outside, a value stored in a column with a type OSON, that's not a data type yet. It will become a data type in 23C. But it's the same thing as storing it into a CLOP or a varchar column. So you load it, you access it exactly the same as you would do with a normal CLOP or varchar. However, under the covers, we are ripping the JSON structure apart and we are storing it in a much more relational and a much more efficient way. So in 23C, we officially introduced the JSON type for both SQL and PL/SQL. From now on, you can declare that a column or variable contains JSON, and we automatically check if the value you want to store in that column or variable is actually JSON. So if the JSON syntax is not correct, you will simply get an error. So what's the fun in this JSON binary format? So by ripping the JSON apart and storing it in a different binary way, we have introduced a lot of improvements in the form of faster query performance, very efficient updates, and reducing the amount of storage needed. So because we store all keys and locations and values in a binary format, we do not have to scan a large JSON document from top to bottom to get the value that the user needs. We simply jump, almost like an index, to the required value and return it. And when doing updates, we do not have to read and update a whole 5 or 10 megabyte JSON document. We only have to update a subset of nodes in the JSON tree structure. So this results in a faster execution of updates and inserts, and specifically less redo on the system. We save storage by not having to store the key field names in several JSON documents over and over again. So like a column in a regular Oracle block, we only store the key or column name once and then write the values in our data files. So storing large amounts of JSON documents with the same key names immediately takes less space than other JSON document stores. And if the values are native Oracle data types like number or date or an interval, we store them in the Oracle native way, reducing again the space needed, but at the same time speed up any extraction of that data. So the new JSON data type is integrated in Oracle's clients drivers since Oracle 23c and higher. So the database itself has also enhanced to leverage the new JSON type in parallel processing, parallel query processing, in-memory columnar store, and things like Exadata Smart Scans. And because we now store the data as individual values in the database and not as a big document, we can easily also add indexes on the values both for single values, so for a single key value combination, but also for JSON keys that have an array as a value. So using multi-value indexes, you can now use an index when you are searching for all the parts that contain subpart 730. It's also possible to put a search index on text on the keys, so you can use a text index kind of search method. So in the below example on the slide, we are trying to find those movies where people commented that they found the movie awful and disappointing. So updating without an overhead. By using the new JSON options, we can also update a JSON document very quickly from SQL if we know which part of the document we want to update. So by using the JSON transform, we directly know which data to update without scanning the whole document. It really saves a lot of time. And if you want to store JSON data in your database, you usually also want it to be complete and contain the information that you expect it to contain, including all the keys that you would require from that particular JSON document. So the Oracle 23c database allows you to declare the structure you expect from values in your JSON column using something called JSON schemas. It's not something we invented. The JSON schema organization describes a declarative language that describes the document and allows you to validate it before you insert it or update it or whatever you want to do. So on the screen you have an example of declaring a JSON schema on the column JSON data. So it, for example, indicates that the value you are inserting is an object, not an array, and that a document that you try to insert or update needs the properties fruit and quantity. So fruit needs to be a string, can be up to 10 characters long, and quantity needs to be a number between 0 and 100. So JSON schemas are similar to the check and not null constraints you would put on a regular database relational column, where you can make sure that certain columns are filled and adhere to certain standards before the record can be inserted in the database. So JSON array aggregation. So back to retrieving information from a relational database. If an external party asks you to provide information in JSON format, either as an object or array, we were already able to construct a JSON document using JSON object in SQL and PL SQL. However, if the information required nested information from another relational table, in our example the employee or M table, we didn't really have a quick solution. So starting 23c, we can now use subqueries while building an array using regular SQL statements. So this should make it easier to generate the JSON information that the outside server or party requires. And if you lose overview of all the JSON this and JSON underscore that functions out there, keep in the back of your mind that more and more of those functions are overloaded into the generic JSON function. In the example, we do the same query as on the previous slide, but this time we use JSON instead of JSON object and JSON array aggregation. So please note that the notation is slightly different, as in the example we do not open with a bracket, but we open with an accolade. We also do not use the value option, but immediately use the colon notation like in a JSON document. And just to confuse you even more, we could have used the colon in the previous examples as well, but I decided to use the value option for demonstration. So things are overlapping each other more and more, and which makes it easier to produce the output you need. So JSON and PL SQL aggregate type. So to make it easier to generate and process incoming JSON documents in PL SQL and perhaps to store them in a database, the database 23c has expanded the options for the JSON and JSON value functions in the database. So before 23c, the JSON value could extract single values from a JSON document, and the JSON function could create a simple JSON document from a series of values. For those people who know their way around PL/SQL aggregates, usually recognizable by their type declarations using record and table, it might be good to hear that in 23C the functionality has been expanded to allow aggregates to be used in JSON and JSON value as well. If you have an array or a record specified in your PL/SQL code, you can very quickly transform the values into a JSON document. Example 1 shows you by simply calling the JSON function and the variable of type record between the brackets. The other way around is also very easy. The second example shows you a JSON value with ID 1 and name Gerald, which is quickly loaded into the variable type of the record. So once loaded, we can use regular PL/SQL code to access the values. And one area I think will benefit a lot from these new aggregate options is generating or storing large amounts of data, either required or offered in JSON arrays. So in the first document, I use a bulk collect statement to read the entire contents of the depth table into a single PL/SQL variable of type table. So once the data is in this variable, I can transform it using the JSON function onto proper JSON and send it to the requesting service. In the second example, I simulate receiving a large JSON array that I want to store in my relational tables. I first use the JSON value to transform the JSON array into my aggregate type variable. Then, as a second line, I use the for all clause to bulk insert the data into my relational table. So both the bulk collect and for all commands were introduced a long time ago for very efficient data loading and writing, as everything is done in bulk, so instead of line by line. Using bulk collect and for all, we can now quickly transport from and to relational values that can be used for writing to the database or further processing. And last but not least, one of our flagship new features, the JSON relational duality views. So with JSON relational duality views, we can now combine the best from relational and JSON storage. So the same data is available both in relational and as a JSON document, but it's only stored once as relational data. So the duality views act like regular views and can combine data from multiple underlying relational sources. So now in theory, to be honest, using the new JSON features I just presented in earlier slides, we could have built our personal view, a normal SQL view that builds a JSON document from different relational sources as well. But the fun part with these relational duality views is that you can also insert, update and delete your data using both relational commands and also using JSON documents. So if you would need to program the processing of an updated JSON document you receive from an outside source, and you need to find out which changes are compared to the current information stored in your database, will probably take a lot of time for each document if you want to write a script and make it available to developers. So now with the relational duality views, after declaring the structure of it, you can specify what can be inserted, updated and deleted in which tables. And the database will do all the hard work for you and make sure that if you receive a JSON document and you insert it, update, delete it, that the underlying relational tables are up to date, including any constraints or triggers on those tables. So using JSON relational duality, you can present the developer with the single JSON document he or she needs for the application, while still keeping the data relationally available for other tools that require the relational data. So building a relational duality view is not that difficult. Just like a regular view, you can first build the SQL statement in a way that it produces the output you need. And then you specify which tables can accept insert, updates and deletes before putting the create JSON relational duality view command in front of it. At least that is how I build a regular view. I first build the SQL statement, the select statement that I think should give me the output I need, and then I put a create view on top of it. So what's new in 23C is the option to use PGQL or GraphQL language in the database and therefore to create the relational duality view. So the second example on your screen shows that the syntax might be a little bit strange in the beginning, but the PGQL language is much shorter than the same statement using regular SQL. Of course, the second example relies much more on foreign key relations between the table than the first one. How to use JSON relational duality views is explained quite a lot on the internet, on blogs on the internet, on YouTube. Oracle Live Labs has a couple of labs on it. So please accept that this is something you definitely need to dive in deeper, and we will continue with the rest of the new features for SQL. So the next 30 slides all contain one feature per slide. So some features really only need one slide, but some of them would need a lot more slides to explain everything in complete detail. Please see the following 30 slides like teasers. I want to tickle you into diving into the full scope of the presented features you like. So here we go. First enhancement, improved error messages. So as explained, we have a new OERR command in SQL+. But the development team has also made a lot of efforts to make it easier for you to identify issues. Not only see that there is an issue, but also give you more information on how to solve the issue or really pinpoint it in your string or in your query where the issue is exactly located. So as a first example, we have a very simple two-number selection and we try to feed it with a string. So in 19C, this would simply result in a ORA 1722. But in 23C, we of course give you the same error, still the 7022, but we also point you to both the letter A and the string ABC that cannot be converted. So I think it should now be easier for you to solve the issue. In the second example, we do a select with a group by, but we miss a column in the group by. We should have put two columns in the group by, both country and state, and we only provide country. So in 23C, we actually tell you which column you are missing in your group by statement. So it's easier to see. And also if you're having issues, like in this case, a connection to another system, or like if you want to address a database link or things like that, we try to make identifying the issue simpler by providing more information. Like in this case, the service name and the IP address and all of these things. In the end, you still need to solve the issue yourself, but at least you have now more clues on where to look for the issue. SQL analysis. So we can assist you when you have an error, we just showed you in the previous slide, but we can now also assist you when you did something less optimal in your SQL statement. Starting 23C, the explained plan of a statement will also contain a SQL analysis report where we identified the most common issues that would slow down your query. Even though this statement would not result in an error, the performance could be improved by considering and using union all instead of just a simple union, or by rewriting the predicates, the where clause. And we also identified that there is a Cartesian product that you might not want in your statement. So if you would fix those three things, your statement would be a lot faster and probably give you the correct output as well. DB developers role. So before developers can start working with the Oracle database, they need access to that database. So we noticed that a lot of DBAs were struggling with the rights somebody should receive when they start developing. So a lot of time the DBA role was simply granted because the DBA didn't want to keep adding privileges or could not be bothered. So starting 23C, we now have a new role with all the grants Oracle thinks are needed for developing applications. It's the DB developers role. And yes, we could have called it the developers role, but apparently a lot of DBAs out there already use the name developers role, and we didn't want to interfere with them. So the DB developer role was created. It grants either directly or indirectly all the rights needed for a developer to work on a single schema on an application development work. So to be able to log in and start querying, the DB developer role is all you need. So just one word of warning, the new role does not include any quota on table space. So if the developer wants to, yes, of course, create a table, but imagine insert data in that table, you need an additional grant to specify which table spaces the developer is allowed to use. Schema privileges. So while we are on the topic of grants and rights and privileges, if you need a developer or schema user to work with tables in another schema, you would need to grant them select, update, delete, or in case of functions, procedures, packages, execute rights. In version 19C and below, this had to be done per object, which meant that if a new object like a table or a function was introduced, a manual new grant would have to be executed as well to that user or to a role. Yes, there are any table privileges or any view privileges or any privileges, but once granted, the user can literally read, in case of an any table privilege, any table in the database, which is probably not optimal looking at security. So starting 23C, we can now grant those any table or any view or any procedure privileges, not only on a global level, but also on schema level to a user or role. So for example, if I grant the select any table on a certain schema to a developer, The developer can execute selects on any table in that particular schema, both on the current tables, but the nice thing is also on all tables that will be created in the future. Longer database password. So as you can see in the error, the pre-23c size of your password for your schema or role was limited to 30 characters. Starting 23c, your password can be up to 1,000 characters. So you will probably need some kind of a system to keep track of those large passwords. I mean, I still need to find a developer who can remember a password this long. But one thing is certain, it will be very secure once you reach the 1,000 characters. A lot of columns in a table. So normalizing table is getting more and more, well, normalized, popular. We already had a limit of 1,000 columns, which we thought was really a lot, but by popular demand, more than 1,000 was needed. So if you set the max columns to be extended, it's not enabled by default, but you have to change an init.order parameter. So set the max underscore columns parameter to extended, and then you have to bounce the database. Your limit has now magically been increased to a maximum of 4,096 columns in a table or view. Word of warning, these large amounts of columns, over 1,000, are only known in the 23c clients and the libraries. So make sure that all your applications that are accessing those large numbers of columns in a table actually use 23c clients and libraries in their connection, or else you will get interesting results. Select word out of from clause. So yeah, small things can change frustration into happiness. And we think that this new feature is one of them. It's a very small change, but well, if you don't have to specify the from dual anymore when querying something, yeah, it might be a lot faster. It's not a big change, but it's, yeah, brings a smile to your face. So when you want to have a value like a sysdate or the outcome of a function, then simply stop typing after the column and don't start with from, but just put a semicolon in the database and it will execute your statement. So just to be sure, under the covers, silently, the from dual will be added before things are parsed and executed. But well, it just saves you some time and frustration. The exist and not exist. So for me, the if exists and if not exists are the also two things in the bring a smile to your face category. Sure, you can program your way around the issue that the table might or might not exist when you write a script in SQL+. And yes, you can simply instruct the end users to ignore any create table errors, but it would be nicer to have a script that simply executes and doesn't give you any errors if there is a table that doesn't exist and you want to delete it. In the first example, the drop table and the create table could result in the ORA 942 and the ORA 955 errors when you did not program your way around it. So in 23c, we can now leverage this if exists and if not exists option. It's a database feature, so it's not a SQL+ feature, so it's something you do in the database inside the create table or the drop table, or the drop function, or the drop view, or the create function, or whatever setup. A bit of a warning, especially if you use not exists, both the options, the if exist and the if not exist, will always return a success, like table dropped, table created, even if nothing has been done. But if you say, well, create table if not exists and the customer table did exist under the covers, it would still say table created, but the old table is not overwritten. The new create table statement is simply discarded. So be aware of this and make sure that you program your way around it. For example, if you really want to make sure that there is a new table structure in there, make sure you first do a drop if exists and then create table if not exist, and then you are good. The table value constructor. So another long overdue feature is the option to supply multiple lines in a single insert statement. So by simply enclosing the values in brackets and then separate them by a comma, you can now insert multiple lines into a table. So please note that the inserts will be executed one by one in the background. So for example, if line 5 fails, the first 4 successful inserts will already be completed in the database. They're not committed, they're still like a normal insert, you can still get a rollback. When you try to insert the example on the screen, you get an error in line 5. be aware that there are already lines in the database. So nothing a rollback will fix, like I said before. But if you fix line 5 and you execute the same insert statement again with the multiple lines, you might end up with duplicate values or your errors with primary key issues because of this. So in the insert statement, to assist you with that, there's also a error logging section that would allow you to log any values that would have failed the insert. And then you can search later on in the error logging to manually correct that. Please check the manual on inserts and DML error logging and more of that for more information. So the values clause can also replace a table statement in a from statement. So if you want to use this construction to use values instead of a physical table, you do have to specify some column names so that the select statement knows which columns you want to reference in the where or in the select statement or things like that. But for the rest, it just works just like a regular select statement. Column positions in a group by. So when writing statements with group by clauses, especially those statements, if you use complex calculations in your columns, it's a bit of a nightmare, because every time you write something in the select statement that is not a sum or having or another aggregate function, you would need to repeat that whole string, that whole set of instructions in the group by clause. And that is not the worst. That if you change something in your select statement because you're still developing, you have to make sure you do the same thing in the group by again, or else you get an error. My first example shows you that I've got a substring and an int string as a column, as a first name, and I have to repeat exactly that in the group by clause. Also, the count star you have is something you need to repeat in the having clause as well. So first enhancement. Starting 23C, you can now use the column position, so 1, 2, 3, 4, 5 in your group by, just like you would do with a order by clause. Which means that if you change the column definition and you've used this column position, you don't have to change the group by part of your statement. You still have to repeat the count star in the having clause. So that's the first part, the column position in the group by, but things can even get a lot better. So the same thing you can do. Instead of column positions, you can now use the column alias as well. So instead of specifying the column position, we can reference the alias you set on a column. So in the example, the 19C part is the same as the previous slide, but on the second part of the example, the 23C part, I've provided both my first column with the substring and int string with an alias, and the count star I also gave an alias. So in 23C, you can now use those aliases in your group by and having. This was already possible in your order by, but now we expanded it to group by and having. So by simply grouping by the alias first name and testing in my having using occurrence instead of count star, I get exactly the same output. And it's much easier to read. You don't have to be afraid that if you change things in the select clause that the group by and the having are not working anymore. This is really one of the very, very nice features. So I can't wait to move some of my internal database to 23C. Also, the returning clause has been enhanced, and for those people, like I use sequences a lot in my coding, and if you want to insert a sequence into a table, but you still want to use that sequence number somewhere along the rest of your coding, previously you would have to assign that sequence into a variable or something like that and then insert that variable. But in 21C, we introduced the returning clause in our statements, where you could actually return the values you inserted or updated in the table. So in my example, I could simply insert the sequence in my table without putting it into a variable and then returning that sequence value into a variable. I mean, it's small steps, but well, programming might be a little bit easier because of that. But it was only the new value that you could return that you inserted or updated in a table. So in 23C, we can now return both the new and the old value in a variable, and we can do this for insert, updates and deletes. So this could be very easy for people doing an update and having the requirement to store the before and the after value in a logging table, for example. Or it could be used to write your own verification process to make sure your application is updating the old value as it expected to update. So this is applicable for both insert, updates and deletes. Of course, for inserts there are no old values, and for deletes there are no new values. but for update you can have both the old and the new value. So if you check the example for the update, you will see the keywords old and new introduced as the indicators for the old and new values. I was a little bit puzzled because now the old and new values and the name of the variable, the name of the column, are separated by a space and not by a dot or an underscore or something else. Only a space, something we just have to get used to. So the defaults in a table. So another enhancements assisting insert and update statements is the default clause for a create table statement, or an alter table statement, of course. So in 19C and earlier we had the plain default clause on a table, and which would simply put a default value in a column when the column was not mentioned in your insert statement. So a lot of applications nowadays, they're not skipping the column or omitting the column. They are simply specifying the value nil in the database instead of just skipping the column. So they are specifying all columns, and the columns they don't have a value for, they simply put a nil in. And the default clause would see the nil value as a value and then not automatically put the default value in there. So in 21C we introduced the default on nil clause, where a default value would still be inserted or used if the column was either skipped or a nil value was inserted. However, if you now update a column and you update it to nil, you would get an error because this new default on null clause puts an implicit not null constraint on the table. So in 23C the default clause was even more enhanced. You can now specify what the behavior is during insert and update statements using either the for insert only or for insert and update. So the for insert only has the same functionality as the default on null clause in 21C, but the new for insert and update will kick in as the options indicate during both inserts and updates. And just to be sure, the regular default clause is also still functioning. And now the Boolean data types. So continuing on changes on table level, we have now introduced the Boolean data type. So we already had a Boolean data type in PL SQL, but not in tables, not in SQL. So starting 23C is now an official data type for SQL as well. That means we can have a Boolean column type. And the big issue while programming this apparently is that because we didn't have a Boolean column before, and Boolean is usually only true and false, people started to create their own versions of true and false, like T and F or yes and no, and sometimes in capitals and sometimes in lowercase. We now have a large list of values that are automatically translated into true and false. So you can insert values into a column type Boolean, and there's a long list of values you can insert, and they will all be translated into true or false in the real Boolean data type. Be aware that all the clients in 23C have never heard of a Boolean data type, and to make sure that those will not result in any errors, they will return a 0 and a 1 instead of the false and true values in your Boolean data type. Make sure you either test that in your application or you make sure you have the proper 23C drivers and clients if you want to make full use of this feature. Direct joins in update and delete. So I'm not sure if this next enhancement is something everybody can and will use, but then again you have to decide for yourself. We can now put joins in our update and delete statements instead of working with subqueries. Well, personally I still prefer subqueries as it's easier for me to read, but perhaps there's a new group of developers and DBAs out there that prefer the other option. So in 23C we can do both, and the result, of course, if you haven't made any errors, will be the same. Extended case control. So although you could already have multiple checks in a case statement, you had to provide the case when and then all your checks. In 23C we try to make writing a case statement a lot easier. It's now possible in this new version to put multiple checks or predicates in your case statement separated by a comma while checking it in your expression. So in our examples, we check if the value p-value is between 1 and 5, and we give it a disagree or not agree and things like that. But especially if it's outside of those values, so if it's lower than null or bigger than 5. In the 19C or 21C version, we had to do a when p-value smaller than 0 or p-value bigger than 5. In the 23C version, you see that it's a lot less typing. We simply say smaller than 1, comma, bigger than 5, and yeah, that's it. It works like a charm. Gives you less typing, and it's probably even easier to read the statements after you've written it, like 6 months later. Sysdate and systimestamp in the time zone. Yeah, migrating pluggable databases to a centralized system, that's very easy, saves you on maintenance. We see a lot of customers migrating their data to a well-protected centralized Exadata, for example. So unfortunately, it turns out that some applications are expecting sys and systimestamp to reflect the local time zone instead of the time zone that has been set up in the operating system. For example, we had a customer in Germany that was migrating his systems into an Exadata system on OCI. In OCI, all of the systems are set to UTC. And then suddenly the customer would get sysdates back in UTC time zone instead of their local German time zone. So of course, one of those ways of solving the things is to change the time zone of the underlying operating system or VM or operating system in the VM. But of course, if you're consolidating databases from multiple time zones in one system, you can't create a VM or a separate system for every time zone because, well, we're trying to consolidate and not get the same mess into one location. So starting 23C, you can now decide that not the operating system will be the base for sysdate and systimestamp, but the time zone set on pluggable database level. So your CDB would still be on UTC or whatever you choose it to be. And then on pluggable level, you can have different time zone settings. So in the example, you see on the left that that's the original situation for a database in our OCI cloud. The operating system is set to UTC. So when I query date on the command prompt, I get Monday, October 2nd at 1 o'clock in the afternoon. And if I do the same thing with sysdate, of course, after formatting it a little bit, I get exactly the same value. So in the first column, you see that the operating system and the sysdate are exactly the same thing. In the second column, you see that I change the time zone of the pluggable database. And I do that inside a pluggable database, of course. So I change the time zone in the pluggable database. I restart the database, I bounce the database, and there's still nothing changed. So changing the pluggable database time zone on a pluggable database level without changing anything else doesn't change the behavior of the system. But if I now change the new 23C parameter time underscore at underscore db time zone and I set it to user underscore SQL, and of course bounce the database again, all calls to sysdate and systimestamp will reflect the time based on the time zone that I've set. So this presentation was written in British summertime and I've set it to London, so you can see it now deviates 1 hour from UTC. If I would have written this into winter time, there would probably not have been a change, but I mean, the example goes, and I hope you understand what I mean. Seal and floor statements. So this slide shows you the enhancements to the seal and floor statements. And for those people who have never used seal and floor before, they work like a round function. Only round follows the international standards, like 5.5 will be 6 and 5.4 will be 5. Seal and floor work in a different way. So seal, like sealing, always rounds up to the next value specify, and floor always rounds down. So if we have 5.5 and we use floor, it will go to 5. And if I have the value 5.1 with seal, it will always round up to 6. So seal and floor have been enhanced to use it with date and timestamp and interval data types. For example, if you want to see all records of the sales that were executed on a certain day, you could use the floor function as it basically by default strips off the time, just like a trunc command, and only returns the day at the beginning of the day. If you do the same thing with seal, by the way, it will always give you exactly the same thing, but then the date of the next day, so the next full day. So by default, as indicated, the seal and floor round up and down to whole days. Optionally, you can specify different values, like in the second example, where we round up and down based on the hour. This makes it a lot easier to give you sets of data based on the hour or on the minute or something else. You can do these things for timestamp and interval data types as well. Talking about interval data types, there's now aggregation possible as well. So normally you could do a sum of a column or a count of a column or the average of a column, but we couldn't do that with interval data types. So I only want to see those jobs that combined, summed up, use more than 5 minutes, something like that. We can do that now in 23C as well. Yeah, just like the example shows you. So if you want to query jobs that have in total taken more than 5 minutes, the example on the screen will show you how to do it. Small things, but sometimes very nice. A bigger thing is the PL SQL to SQL transpiler. That is actually a very nice. When you are writing SQL code, it needs a little bit of explanation. So when you're writing SQL code, you sometimes need to write PL SQL or want to write PL SQL because some functionality is not available by default in SQL, or it's very complex and you want to simply standardize things and you want to write a function. So in the example on the screen, I've written a small function to extract the first name out of a name offered. And I know the function is not complete. It uses an int string to get the space, and then it uses substring to get the first part of that string out, and we assume that it's a first name. Yeah, I know it's not complete because people can have multiple first names, or I know, but it's an example. It needs to be simple. So the downside of this setup when using this first underscore name function in a select statement is that if you're executing your SQL statement, every time the SQL engine hits this little bit of custom PL SQL code, it will stop what it's doing. It will pass the information it has to this PL SQL engine, who will then calculate it in a separate process to see what the first name is. It will return the first name after the PL SQL stuff has finished, push the information back to the SQL engine, and then the SQL engine can continue to the next record. If you have 1 million records, you will see 1 million switches between SQL and PL SQL. And this switch is really costly. It's called context switching. If you would write the statement and only use plain SQL functions, I've tested this, the throughput in the same system is 10 times higher. So it's 10 times faster if you write this either with this simple function I've written in PL SQL and use the PL SQL in the select statement, or if you simply run it as a native SQL thingy. Now this is where the SQL transpiling comes in. So transpiling is a word, it's a combination of translating and compiling. It basically means we are changing something, but we want the output to be exactly the same thing. The SQL transpiler will try, and be aware you have to enable this with an init.or parameter, etc., but it will try to rewrite the PL SQL part of the SQL statement to be rewritten in exactly the same thing, but this time in SQL. My example that works, that can be transpiled, will actually be rewritten. So it's not a very dumb, let's put this into that. It actually goes through the lines because I've used a variable and I've used a return and all of these things and a parameter that comes in. And it can actually rewrite this into, like you see on the screen, the substring name 1, int string name, whatever. And it works. The developer can still continue to use custom PL SQL functions to make things easier to read and easier to see, but the speed will be native SQL engine only. So of course this does not work with all custom PL SQL functions. It's a start. It doesn't work with a function in a package, for example. It has to be a plain function, and of course can't be any loops in there but things like if then else can be done, and variables can be done, and there's a lot of things. So please check the manual on how to enable it, because I think it's a fantastic feature, but also at the same time check which restrictions we have. Very nice feature. So last but not least, the SQL Firewall in 23C. Oracle already had a SQL Firewall product, separate product, you had to install and put, as far as I know, in front of your listener. But starting 23C, this functionality is now incorporated in the database, so you don't need a separate product. With SQL Firewall, once enabled, you can determine which statements are regular statements for your application and can therefore be executed. So you first have to train your SQL Firewall to tell them which statements are good, which statements are not good. But once you enable it, only those statements are passed to the application and the answers are returned. So this is largely to prevent SQL injection in your database. But be aware, it's not only the SQL code that is being checked. You can also put restrictions on the, for example, operating system on the client side that is executing the statements, or on the IP address where the statements are coming from, even the client process name on the operating system. So if you expect certain queries, certain statements to come from your application name.exe and it suddenly comes from SQL+.exe or SQL developer.exe, you can say, well, I don't care what you do, even if it's a good statement, sorry, end of story, we're not going to help you. There's a lot of other parameters as well, by the way, that you can use to determine whether or not the statement is good or not good. So if the SQL firewall thinks that there's something bad going on, it will not give you an error, which is, I think, really good, because hackers learn a lot from errors. The SQL firewall simply returns a nil value for the query executed, like no columns were there. So even if the hacker thinks it's now got the perfect statement to get all the passwords or all the usernames out of your system, it will simply get a nil value back and thinks, well, okay, I might have done a where wrong instead of knowing that the whole statement was wrong. And the SQL firewall has, of course, extensive logging to see what went well, what went wrong. You can also put the SQL firewall simply in logging mode, so it doesn't enforce the restrictions on the system. It's really like a firewall, just like a normal firewall in the system. It will work best if you have an application that always sends the same statements to the database. Of course, if you have an application that builds its own statements dynamically, you will have less fun with this. But still, you might be helped with things like the source IP address or the source application name, something like that. So those were the enhancements on a single slide. So the last 5 new features are not specifically more important than the 30 we already covered, but I wasn't able to explain the new features on a single slide, so my bad. So here we go with the last 5 new features during this session. So the log-free column reservations. Thinking about this, I mean, when Taylor Swift, the rock star, communicated that concerts were planned, at least in the Netherlands, and that concert tickets were available, the systems selling those tickets, although warned several times, were overwhelmed and sometimes even crashed. They simply could not handle the sheer number of people trying to get tickets from the system. So with this in mind, not looking at the application, but simply wondering how this would work inside a database in Oracle 19c when we try to sell something, when you had like 40,000 tickets. So if you do it the stupid way, I mean, this is an example, I'm allowed to be stupid. If you do it the stupid way, and I've created a table where every location has a number of tickets. By the way, these are actual dates for the concerts. And not all of them, I mean, there's a lot more concerts, but for example, in Nanterre in France on the 9th of May 2024, there are 40,000 tickets to be sold for that system. If you do it this way and you would want to sell a ticket or a couple of tickets, we would basically lock the row that holds the tickets for that venue. No other session would be able to lock that row to sell more tickets until the lock was released, for example, after paying of the tickets. So can you imagine when 1,000 people want to buy tickets for Nanterre in France at the same time in parallel? That would be a nightmare for the application because the database couldn't simply do a lot more. Now in 23c we have a new feature called log-free column reservations, and it was introduced specifically for Taylor Swift. I mean specifically for these kinds of situations. So the keyword is reservable. So it can only be a number column, and you can add the extra word reservable on that column. Table creation then follows like it should be. You can insert your data into the new table, nothing has changed. It becomes different when you try to update those columns. So once the values are inserted in the table, the only thing you can do with the columns that hold this reservable flag is adding or subtracting tickets. So ticket equals ticket plus 1 or ticket equals ticket minus 1, something like that. So in the example with the label session 1, you see that the application can update the table. We are reserving 1 ticket for the concert with ID 1. Strangely enough, when I tested this, although the update reported successfully, when you do a query on the table, you don't see the fact that you removed 1 ticket from the queue. It doesn't reflect the changes. This is different from columns without a reservable flag, because if you would do this on a column without a reservable flag, you would see 39,999, even before the commit has been executed. Session 1 reserves a ticket, Session 2 reserves a ticket. Although Session 1 has not made a commit, Session 2 can, without any problem, still reserve a ticket. Session 3 can do an update statement as well at the same time. The trick is that the actual updates we do, without committing them, they are stored in a kind of a journaling table, a journaling structure in the system. And we keep track of the session IDs and the updates they've done on the columns. So if the session does a commit, then automatically the commit is in the database. The value will be finally subtracted or added to the column value, and the journal entry will be deleted. Example, if I have session 1 here and I do an update of a row and I do a commit and I do a select, then I see my ticket being subtracted from the row. Same goes for session 2, same goes for session 3. Yeah, committing the transaction will make the value visible, and of course committing means that the ticket is now gone or sold or whatever you have. So for the Taylor fans, it would be really great if more tickets can be sold than there is space in the venue, or might not be nice, I'm not sure. Basically, we need to make sure that the column value does not go lower or higher than a certain value when you're making the reservations. So the basic calculation should be that the column value you have stored in the database plus or minus all the uncommitted transactions that are in the journaling system, they need to be controlled. They need to be maximized and minimized. Well, this is what we do with a simple check constraint. The check constraint will make sure that the total number, so both the actual value plus or minus the uncommitted journaled values, are checked every time an update is done. So even though the column value might not reflect it when you query it, you still might get a constraint violation if the total values leads to triggering of that exception. So let's say there are 40,000 people in parallel buying a ticket, number 40,001. Even though the table still says 40,000 tickets available and the user 40,001 comes in, tries to do an update with -1 ticket, it will simply get a check constraint violation violated. So that's the updating part. If you try to delete a record, okay, let's hope Taylor doesn't get sick and we have to delete the entry in the system. But if you want to delete a record out of a table that has this reservable flag on a column, it means that there are not allowed to be any transactions going on that row. So no journal entries on that row. If you try to delete a record in a table that holds the uncommitted journal entries, the system will try to delete it. If there are still entries, it will wait for 5 seconds to see if the transactions perhaps will be committed and the journal will be released. But if there is still journaling going on after 5 seconds, it will issue a new error, the ORA 55754. So good things and bad things with the reservable stuff. Another very nice feature is JavaScript inside the 23C database. So another subject that needs a few more slides is this JavaScript thing in 23C. We can now use JavaScript in stored procedures and packages. You can completely exchange PL/SQL inside functions, procedures and packages by writing the same stuff in JavaScript. And once created, the function or procedure or package can be used like any other PL/SQL function in a query or other procedures and packages. So if I have say hello here as a function completely written in JavaScript, I can simply say select say hello between brackets my name, semicolon, not from Joule because we don't need it anymore. And that will be executed the same way as I would have written this in PL/SQL. So once running, the moment a query or a section of code finds a piece where JavaScript code needs to be executed, it will send it to the new multi-language engine inside the database, or Graal VM. It's similar to the Java engine, the Java VM engine, and the PL/SQL engine that we already know in the database. And the speed is comparable, and well, it depends of course on what you're doing inside the JavaScript, but well, speed is comparable to either Java or JavaScript or PL/SQL. So on the screen is an example of a very simple JavaScript function that takes a variable pperson, puts an hello in front of it and returns it to the calling process. And what I find very nice is that I can define a parameter in my create function, and I can use that parameter inside my JavaScript as it were a local parameter in the city, in the code. In this example, we are not using any JavaScript libraries, and of course libraries are very nice in JavaScript as well. Because if you know how to write JavaScript, you can now program the functionality you want in the database without the need for PL/SQL. In general, the nice thing about JavaScript is that there are a lot of libraries out there where very smart people have already programmed a lot of things that we could need in day-to-day programming. So fortunately, we can also use those external libraries inside the database and inside the JavaScript code inside our database. So the only thing you need to do when you need a library is to create them inside the Oracle database. You can simply do that by loading them from the operating system. So the .js you have on your operating system, you load them only once inside the database. But once you've loaded them inside the database, you can reference them inside your code, just like you import a module in your JavaScript code. We even added an extra layer called module, because you might have a library version 1 and a library version 2. In that case, you can have two different modules with the same name, but in this module you can have the same extra information like you need for versioning or environment variables. You could even have different modules pointing to different versions of a JavaScript module, like I indicated. So you could actually use all the pieces of code and make sure that your pieces of code are still working with the old library where it used to work with. So when creating procedure and functions, as I demonstrated in the previous slides, you can directly use them in either SQL or PL/SQL. So even if you don't want to code your way around the modules that you import into the database, you can even expose the functionality of an entire module or entire set of functionality in your JavaScript library without writing the JavaScript code around it. By simply like I show you on the screen, just create a package where you create a new function or a new procedure and simply point to the module, point to the Java library and point to the function inside that library. So it's very easy to expose libraries and functionality of libraries inside SQL and PL/SQL without writing a lot of code. And the last thing I'm really enthusiastic about while using JavaScript and working with the database from inside the database is that if you want to retrieve information from the database, I mean, if I write something in PL/SQL, I would simply create a cursor and a for loop and do everything I can do in PL/SQL. But if you write in JavaScript and you don't know how to write it in PL/SQL and you still need the same data, you can write your own loops, of course, in the JavaScript. So in regular JavaScript, you would first need to create a connection, build a connection, and you would need a username, a password, a connect string, all of these things, and you have to wait until the connection has been built by the database before you can actually start doing your magic in the database. Now if you execute the same script from inside the database, so with the new JavaScript functionality in 23C, you don't need a new connection as you are already connected to the database because you are executing this in the database, so you don't need a new connection. You do not have to supply a username, a password or a connection string. You simply ask for the connection reference from the MLS.js Oracle DB module, which is there by default, and you can start doing your actions right away. So no issue with dropping the connections afterwards. It's all there because there's only one connection. So all in all, I hope that this new JavaScript feature for 23C will attract a lot of developers who do not really know PL/SQL language, but they want to work with the Oracle database. Or make it easier for companies to hire new staff to work with the Oracle database because they can find people with JavaScript experience and not with PL/SQL experience. Let's hope. I really like the option. And now application usage annotations. So the new feature application usage annotations, they allow you to add key value pairs as custom properties to a database object like tables. But also views, materialized views, columns, indexes. It's basically similar to the comment option we already had in the database, but using the new annotations, we can store multiple keys with optional values in the systems. So the annotations are stored inside the database, but they're not really used or interpreted by the database in any way. So your query will not slow down based on the number of annotations on your system or your update or your delete. So you can add, update, remove annotations using the regular create and alter statement. So there's no create annotation or alter annotation command. It's the create table annotation and then you change it or update it. It's the same statement you would use for creating or altering a table or index. So I'll give you some more examples in the next slide. So here's an example on how to work with multiple annotations in one table. So it also shows you a little bit the use of the double quotes for those annotation keys that have a different case or keywords or things like that, but also things about updating and deleting an annotation. So in the example on the screen, you see that we are first replacing an existing annotation. So it's called my lowercase annotation, and I'm replacing it by the value lower value. So there's no semicolon or values clause between. It's just the command replace, then the name of the annotation, the key of the annotation, and then the value of the annotation. Second line shows you how to drop an existing annotation. And the third line is how to add an annotation. By the way, you can skip the add word as well, because that's the default value in a system. What is nice is the example that the value of the annotation, by the way, both can be maximum 4,000 characters long, is that the value of the annotation can also be, for example, a JSON object. So you can use annotations any way you like. For example, you could label all columns that contain an email or a certain customer ID. No matter the name of the column, you know that there's an email inside. So in case if you need to, I don't know, update or check all the email addresses, you can simply query the database. Which of my columns actually hold email addresses, or which of my columns actually hold customer IDs. You can also, if you use a change request system, you can keep track of which internal change request actually caused the column to be added or removed or things like that. The possibilities are endless. It's a key value system, and you can store any key or value in there you want, as long as you don't reach the 4,000 characters. The same line of things is usage domains. So with annotations, you put key value pairs or just key values as information in the database. Usage domains go a little bit further. To say, well, of course you can put annotations inside the usage domain, but you can also put some database side requirements or rules on those columns. And if you use them on the same column, for example, I use it on an email address in the database. You specify the rules where the email address needs to adhere to. You only specify the one in the domain as a master layout. And then you can apply this domain to all of the columns that contain email, for example. So without constantly programming or put long lists of check constraints in your database, you can still make sure that the email always behaves the same way, that the same regular expression also is applied. So in this example on the screen, we've created a domain called dom_email. And we want to make sure that there's always a value in the record, like a not null constraint. And even if the value is null, we want to make sure that the email address adheres to certain regular expressions. And so I've put the default value unknown@domain.com in there. So there's always a value in there. And the email addresses that you do try to insert in the system, they have to adhere to a certain regular expression check. So first a couple of characters, then an @ sign, and another characters with a dot. And then last but not least, we indicate that if you use this domain on a column, it should automatically have an annotation that this is email. And the second annotation is that the PII confidentiality, so the personal identifiable information, has a confidentiality setting of high. And we simply apply this with one single command on the email column in this case. So this way, all the columns with a email value in that column and where the domain has been applied, they will simply adhere to those rules that you've set up. So it might make your database administration a lot easier. So once applied, here are some examples on what it looks like in real life. So in example 1, we show you how to use the domain display function. It specifies basically how you would like to see the contents of the column, always in the same way. So when called, in this case, the display rules that we have stored in the domain, they will apply to the column. And in our case, the part before the @ sign has been replaced by hidden. Not sure if this is really helpful, but it was a nice example. So the column itself is of course still displayed as a normal column. This function, this domain display function, is not the same as SQL redaction. SQL redaction would actually prevent you from querying the data in a readable way. But it might help you to make sure that if you have an application, all of your applications need to display the email address exactly the same way if they're not used by the user, then you can use this domain display. So in the second example, I try to insert a value in the email column that does not really adhere to the regular expression that I've done. So it automatically gives off a check constraint based on the domain value. And in the third example, I show you what happens if I enter a nil value into the records of the column. So it will just insert the default value unknown at domain.com. The fourth example is not really an example on domains, but it shows you what happens if you use the describe function in SQL+, describe table function. So it will not only show you the columns and the column type, but if there is a domain added to that particular column, it will show it as well. So it's easier to see which columns have domains on them and not. So that's it for usage domains. Property graphs, the last function for today, is a new functionality inside the database. And if you think about graphs as in pretty pictures, a lot of people think about that, but it's not the same thing. So if you've never heard of property graphs, please look at them, because it's a wonderful new way of doing things. So for those unaware, the regular SQL we write, we base it on relational tables, and we base it on matching rows and columns of the tables that we already know and the columns that we match on the system. And we know exactly how many columns we need to access. Whereas with graph technologies, we rely on the connections between data entities. So for smaller queries, it might be a matter of taste if you use either the PGQL language or the GraphQL language or normal SQL. So for example, in the example on the screen, you see a regular SQL statement and a GraphQL way of finding out how many airlines fly between Hamburg, Germany and London Heathrow. The table contains all the flights all around the world. And we simply say, well, I want to have the source equals Hamburg and the destination reaching London Heathrow. We know that there are only direct flights, this query will only show us which direct flights are there from one airport to another. You can still use both ways of querying data, and it's still pretty readable. So it will be different when we don't really know exactly how many hops are between the source and the target. And like in this example, if other transportations like trains are needed to reach your destination. So in the case on the screen, the query checks in how many different ways we can get from downtown Paris to downtown London. And in our case, because there's no airport in downtown Paris and there is no airport in downtown London, well, I know it's London Docklands, but it's not downtown London, it would require a transport to an airport for a train, for example, and then a flight, and then another bit of transport. So if you want to program this into regular SQL, you would need a lot more lines compared to the GraphQL example. So especially if you want to add additional stops in Amsterdam as well, so Paris, Amsterdam, Amsterdam, London. GraphQL has been created especially for this. So the big thing is that you used to need an outside engine to perform these queries. So you would need to export the data from the Oracle database, import it into the Graph engine before you could actually query the data. So starting 23C, the data can be accessed directly by GraphQL. There's also a couple of new table types and a couple of new options, but it can be executed directly from the Oracle database. So you can try to write something in SQL, and maybe the same thing can be much easier, much quicker, be written inside the Oracle database. Most clients are now able to see and use GraphQL like SQL Developer and things like that. And also a lot of applications are also enabled to process the output and create the nice graphs you see on the screen. So very nice feature, GraphQL. If you never work with it, again, dive into it. It's a very powerful way of showing relations between various systems and various people. So this concludes a long, but again, not complete list of new features in SQL for 23C. If you want more information, please check the 23C New Features Guide, which is out there in the documentations link. You can check a lot of live labs that are written based on functionality for 23C. You can download and of course play with our completely free Oracle Database 23c free offering. We have a new feature session every week. So every week we talk about a new feature in the 23c. Those are the 23c weekly new feature session. There is a lot of information out there. So thank you for watching. This is the end of the presentation. If you have any questions, please let us know. For now, again, thank you for watching and hope to see you soon on a next presentation.